This next section deals with induction and deduction. So the textbook defines it as induction means arranging an argument so that it leads from particulars to universals, using specific cases to draw a conclusion. Now, we use induction in our everyday lives. The process of induction involves collecting evidence and then drawing an inference based on that evidence in order to reach a conclusion. To write an inductive argument, you would support your claim with a series of reasons explained through concrete examples, and that would be arguing inductively. Arguments developed inductively can never be said to be true or false, right or wrong. Instead, they can be considered strong or weak. This is an important point, that I'll cover some more in a second. Essentially, an argument structured inductively cannot lead to certainty, only probability. Hopefully you read this example of induction in practice. If you didn't, I would pause and reread. Okay, deduction. When you argue using deduction, you reach a conclusion by starting with a general principle or universal truth, a major premise, and applying it to a specific case, a minor premise. Deductive reasoning is often structured as a syllogism, a logical structure that uses the major premise and minor premise to reach a necessary conclusion. We see that here. Our major premise is exercise contributes to better health. The minor premise is yoga is a type of exercise. Conclusion, yoga contributes to better health. So notice when we reread our definition here, you start with a general principle or truth. I think we could all agree that exercise is good for better health. Apply it to a specific case, in this case, a specific form of exercise, and that brings you to your conclusion. The strength of deductive logic is that if the first two premises are true, then the conclusion is logically valid. Keep in mind, though, that if either premise is false or questionable, then the conclusion is subject to challenge. Major premise here, celebrities are role models for young people. Minor premise, Kim Kardashian is a celebrity. Conclusion, Kim Kardashian is a role model for young people. So you can challenge this conclusion by challenging the veracity of the major premise, right? If you don't agree that celebrities are role models for young people, then this entire syllogism would fall apart. So if any premise is faulty or perhaps questionable, then the conclusion is going to be negatively affected. Okay, here's another example. Major premise, women are poor drivers. Minor premise, Ellen is a woman. Therefore, Ellen is a poor driver. Breaking this stereotype down into a syllogism clearly shows the faulty logic. Perhaps some women, just as some men, are poor drivers, but to say that women in general drive poorly is to stereotype by making a hasty generalization. It's a logical fallacy that we've talked about. Breaking an idea down into component parts like this helps expose the basic thinking, which can then yield a more nuanced argument. So again, when we think about if any part, whether it's the major or minor premise, normally it's the major premise, if it's faulty in any way, if it's generalization, if it could be questioned, if it could be challenged, if it's based off an assumption, then it's going to fall, the entire thing is going to fall apart. Now here, we're going to talk a little bit more about combining induction and deduction in a minute, but hopefully you read through this example and then their explanation down at the bottom here. Okay, they can break it down into this syllogism. The major premise of citizens have a right to rebel against a despot. King George is a despot, therefore the citizens have a right to rebel against him. Okay, but notice that it also uses a bit of induction as well, which is explained here. Okay, now let's go into a little bit more in depth about this topic because I know it can be potentially confusing. So let's look at some additional examples and definitions that I have here. So another way to think about the difference between induction and deduction is deduction moves from idea to observation, while induction moves from observation to idea. Deduction is an idea first, followed by observations and then a conclusion. Think about that major, minor premise and conclusion. The syllogism is part of the deduction. Induction is observation first, followed by an idea that could explain what's been seen. The big difference is that deduction's conclusions are bulletproof, meaning assuming that you don't make a mistake, a deduction will be true. The conclusion is always true as long as the premises are true. With induction, you don't get absolute certainty. You get a generalization, you get a likelihood, you get a prediction. A lot of times when we think of logic, we can think of you can start with induction to get a generalization and then move to deduction to try to come up with a more solid conclusion. Okay, so let's look at some examples here. All men are mortal. Harold is a man, therefore Harold is mortal. Okay, this is deduction. The third sentence is absolutely true because the first two sentences are true. There's absolute certainty here. We know that everyone dies, and we can say, I guess, based on biology, that Harold is male. Okay, therefore, we can say with absolute certainty that this conclusion is absolutely correct. Here's an example of deduction. I have a bag of many coins, and I've pulled 10 at random. They've all been pennies. Therefore, this is probably a bag full of pennies. Okay, induction. This gives some measure of support for the argument that the bag only has pennies in it, but it's not complete support like we saw with deduction, right? It's a generalization. It's a prediction. Okay, some more things to think about. Deduction has theories that predict an outcome, which are then tested by experiments. That's where we then come up with truth. Induction makes observations that lead to generalizations for how that thing works. If the premises are true in deduction, as we talked about, the conclusion is definitely true. If the premises are true in induction, the conclusion is only probably true, depending on how good the evidence is. Deduction is hard to use in everyday life because it requires a sequential set of facts that are known to be true. Normally, deduction is going to be where you sit down and really map out an entire problem, find support, find evidence, and then try to have a certain conclusion. Induction is used more so in everyday life because most of the world is based on partial knowledge, probabilities, and the usefulness of a theory, as opposed to its absolute validity. Deduction is more precise and quantitative, while induction is more general and qualitative. Qualitative, again, means the quality of something. Quantitative means specific numbers. So that would make sense that this would be precise and this would be general. Okay, so let's look at some examples here. Since all squares are rectangles and all rectangles have four sides, all squares have four sides. This is precise. It's definitely true, especially when we see these major and minor premises. It includes a set of facts that can be backed up. Now, induction example. Ray is a football player. All football players weigh more than 170 pounds. Ray weighs more than 170 pounds. Now, here's the observation. Okay, notice how here, this is kind of a generalization, right? All football players weigh more than 170 pounds? I mean, likely, but do we know that for sure? Have we done the research? Is there specific data that says every single football player, whether it's college, high school, NFL, they all weigh more than this? I mean, it's likely, but we don't know for sure. We don't have the stats in front of us. So here, when we say Ray weighs more than 170 pounds, that is a generalization. That is a prediction. We don't know for sure. If we really wanted to find out exactly how much he weighed, we would have to go through the process of then deduction to figure out exactly how much he weighed. So this is probably true, but not definite. Okay, here's a little chart that I think, or a visual aid that hopefully makes things a little easier to think about. In deduction, you go from theory to then hypothesis to then an observation. So here's where your evidence would come in, well, more so in your observation. And then the confirmation would show that something is definitely true or not. Induction starts with an observation. You then try to find patterns that fit that observation, a tentative hypothesis, and then a theory. So notice how if we end with a theory here for induction, we could then start with a theory in deduction to confirm if that observation is true. So notice how induction and deduction can be used together. So some more things to consider. Deduction gets you to a perfect conclusion, but only if your premises are right. Deduction moves from theory to experiment to validation, where induction moves from observations to generalization to theory, as we see here. Deduction is harder to use outside of a lab science settings because it's often hard to find a set of fully agreed upon facts. Induction is used constantly because it's a great tool for everyday problems that deal with partial information and come up with usable conclusions, but they're not always 100% accurate. Be willing to use both types of reasoning to solve problems, as we just mentioned, and know that they can often be used together as a pair. Use induction to come up with a theory, then use deduction to determine if that theory is actually true. And the main thing to avoid with these two is arguing with the force of deduction, guaranteed to be true, while actually using induction. If you're using induction and you're claiming something is absolutely true, you're going to look bad, because if you use induction, you're only talking about probabilities based on strength of evidence. If your evidence isn't strong, your argument's going to fall apart.